Hey, what's up? It's your old pal, Mr. Cook, and we're going to go through the extra review for Unit 10. So I'm assuming that you've already watched the first review. So some of this stuff I think is going to be pretty self-explanatory. It's really just about like doing another example of each of the different things. It looks like they're a little out of order too. It looks like there's more problems also. Whatever. Okay, let's go through them. All right, so classify each conic section. So ask your 3 questions. So the first question is, do you have both an x squared and a y squared? So let's do these all at once, okay? So question number 1 is, do you have an x squared and a y squared? If you say no to that, that means you have a parabola, okay? So let's look for some parabolas. Let's hunt them down. This one has an x and a y squared. This one only has a y squared, so this is a parabola. This one will only have a y squared on it. That's it, no x squared, so parabola. This has an x and a y squared. 2 has an x and a y squared. 4 has an x and a y squared. 6 has an x and a y squared. 8 has an x and a y squared. Okay, so we have 2 parabolas, number 3 and number 5. Okay, next question. Do x squared and y squared have the same sign? If you say no, then that makes them hyperbolas. So let's hunt down some hyperbolas. So the x squared and the y squared are both positive here. So no, that's okay so far. X squared and y squared are both positive here. Number 4, looks like we have a negative y squared and a positive x squared, so that makes this one a hyperbola. 5 is already a parabola. 6 has a positive x squared and a positive y squared. 7 has a positive x squared, but a negative y squared, so this is also a hyperbola here at number 7. And then 8 has a positive x squared and a positive y squared. So those are the only hyperbolas, number 7 and number 4. The next thing that we would ask ourselves is the last question, number 3, and that's, so we have x squared and y squared. We have them both as the same sign. Now, do x squared and y squared have the same coefficient? If no, then it's an ellipse. Otherwise, it's a circle. So looks like this one has a 1 and this one has a 4. So this is different coefficients, so ellipse. Number 2, yeah, it looks like they have a 1 and a 1 here, so that makes this a circle. 4, we have a positive 1 and a positive 1 out front, so this is a circle. And then for the last one, it looks like we've got a 1/5 in front of the x squared and then a 1/15 in front of the y squared, so they're different. So that makes this an ellipse. So that means that the last ones are circles. Okay, so like number 6 and number 2 are both going to be circles. And you can just look at the form of number 6 and tell it's a circle. I don't know. You didn't need to go through those questions to see that that's just a circle equation. Same thing with 8. 8's clearly an ellipse equation, right? Because you're adding the x squared and the y squared, and then you're subtracting the x squared and the y squared for 7. So that's clearly a hyperbola. And 5 is clearly a parabola because it's only like a square for the y value. Okay, so there's the first 8. Next up, use the information provided to write the standard form equation for each circle. All right, so a circle looks like this. The standard form is x minus h squared plus y minus k squared equals the radius squared. So just, fill in the blanks. So that's, h and k for each of these, and then that's r. So for number 9, 1 is going to be h, negative 8 is k, so that turns into a plus, and then radius is 3, so that changes to a 9. Okay, and then for number 10, let's see, so h is negative 5, so minus negative 5 changes to a positive 5, and then minus k, so minus 7, and then square root of 53 squared is going to be a positive 53. So there's number 10. Identify the center and the radius of each, and then sketch the graph. Well, when it's in standard form, this is really easy. It's the opposite of the number in the parentheses, so negative 1 for the x value, and there is no parentheses, right? Or is there? That turns into y minus 0 squared if I, were so bold. So I'd say that 0 for my y value, so that's the center. And then the radius, well, this is r squared, right? So that means that r, the radius, is square root of 16, which is 4. So graphing it out, I go to the left, 1 up 0, there's my center. And the radius is 4, so I go up by 4, down by 4, to the right by 4, 1, 2, 3, 4, and then to the left by 4. And then, just like graph it out as best I can. There we go. That's a circle. It might not look perfect, but you know what? Beauty is in the eye of the beholder, guys. Okay? That looks like a beautiful circle to me. All right, next up, looks like we've got opposite of -3, so that'd be a +3. Opposite of positive 1, which is a -1. So that means that our circle is going to be located at the center is 3, -1. And then the radius, well, if r squared is equal to 4, r is going to be equal to 2. So we go to the left and the right by 2. We go up and down by 2. And then we draw. Okay, there's our circle. Next up, use the information provided to write the transformational form equation of each parabola. What the transformational form? I guess that means the standard form. I don't know. Whatever. Yeah, I'm sure that's what they probably mean. Okay, so let's see. If I graph this thing out, let's see. -5, -11 will be like in the third quadrant. So -5, 1, 2, 3, 4, 5. Then down 6, 1, 2, 3, 4, 5, 6. There's the vertex. And if I go down 5 more, 6, 7, 8, 9, 10, 11. That's the location of the focus. So remember what we said. If you have the vertex and the focus is inside the parabola. So my parabola is going to look something like that. And that means it's moving up and down. So the x part is going to be the squared part. So I'm going to be using this equation. X minus h squared is equal to 4 times p times parentheses y minus k. So y and k come from the vertex. Or sorry, h and k come from the vertex. So plug those numbers in. H is -5. K is -6. And then remember that the focus is a distance of p away from the vertex. So how far away are these two coordinates from each other? Well, the x values are the same. So how far away are the y values? -6 to -11. That's a total distance of 5. So my p value is equal to 5. And not just 5, it's also a -5 because my parabola is facing downwards. Hence, it has like a negative direction to it. Okay, so let's make this thing look a little nicer. X plus 5 squared equals 4 times -5 is -20. And then y plus 6. And there's, I guess that's transformational form, I think. Okay, vertex and focus. So it looks like the x values are going to be going pretty far. So we've got 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 3, 1, 2, 3. There's our vertex. And then the focus is one further away from there. So there's F. And remember that the focus is inside the parabola. So that means that my parabola is going to be opening up to the right. Now, if it's opening up to the left or to the right, that's when I've got a parabola of this form. Y minus k squared is equal to 4 times p times x minus h, where h and k come from the vertex. So, just plug those numbers in. So h is 10, and then k is 3. And then how far away are, the focus and the vertex from each other? Well, it looks like their y values are the same, so it's the difference between the x values. How far away are the x values from each other? They're a difference of 1. So my parabola p value is going to be 1. And since the parabola is pointing to the right, that's a positive x direction. So that means that technically, like, it's going to be positive for the p value. So I can just leave it as a positive 1. And yeah, I mean, this is actually like pretty close to the way I'd want to write it. I just maybe multiply the 4 and the 1 together to make 4. But that's my parabola formula. Okay, there's the first 14 problems, and that concludes the first page. So I guess that'll be the first video, and then I'll move on to the next video, see what we got there. Okay, see you then.